Hi everyone, in this video we will discuss about superposition theorem. In previous videos we have discussed about Thevenin's theorem and Norton's theorem. Here we are going to discuss about superposition theorem. So first we will see the statement of superposition theorem, then we will see the explanation of superposition theorem. Superposition theorem states that in any linear circuit containing multiple independent sources, the current source or voltage source at any point in the network may be calculated as algebraic sum of the individual contribution of each source acting alone. Suppose two sources are connected in network. So at a time we have to take one voltage source and we have to find out the current. And in another case we have to take another voltage source, and first voltage source we have to deactivate and another voltage source we have to activate for find out the current. And so those two currents we have to take algebraic sum. So first case current and second case current if you would take, so that is the resultant current in the element. Similarly current sources also, so any one source we have to take at a time. So that is the statement of superposition theorem. So once again we will see the superposition theorem statement, then we will move to the explanation of superposition theorem. In any linear circuit containing multiple independent sources, one or two sources, either it may be two voltage sources, either it may be two current sources and one voltage source, one current source in the network car circuit, the current or voltage at any point in the network may be calculated as algebraic sum of individual contribution of each source acting alone. So this is the statement of superposition theorem. So procedure, action plan. In a circuit comprising of many independent sources, only one source is allowed to be activated in the circuit. The rest are deactivated. To deactivate a voltage source, replace it with a short circuit. To deactivate a voltage source, replace as a short circuit. And to deactivate current source, replace as a open circuit. What we procedure you followed previous theorems, Norton's theorem and Thevenin's theorem. Similar procedure we have to follow for deactivating sources. The response obtained by applying each source one at a time. So only one source we have to consider at a time, then added algebraically to obtain the solution. So we have to add those cases. So resultant either if you are calculating voltage, if you are calculating current, we have to add currents, both the cases voltages, then you can obtain the solution. So this is the procedure, this is the explanation for the superposition theorem. So limitations are very important for your exams. So limitations also sometimes they will ask, write the limitations for superposition theorem and explain superposition theorem statement. Superposition is a fundamental property of a linear equations and therefore can be applied to any effect that is linearly related to the cause. So linear equations, linear circuits only we can apply this superposition theorem. Non-linear circuits, non-linear elements we cannot apply superposition theorem. That is, we want to point out that superposition principles applies only to current or voltage in a linear circuit. So only we can apply current or voltage, but it cannot be used to determine the power values we cannot determine, because the power is a non-linear function. Finally, what we can say, superposition theorem is applicable only linear circuits and linear parameters. So current or voltage values we can find out, but power is a non-linear quantity, we cannot find out using superposition theorem. So power values will not satisfy the superposition theorem. So only So we can determine the current and voltage in a linear circuit. Power values we cannot find out. So power values if you find out also, those values will not be correct. So this is about limitations of superposition theorem. Then we will move to the problem. So these problems are very important, little bit different than the previous theorem, Norton's and Thevenin's theorem. So superposition theorems are little bit different. So you have to use voltage source or current source at a time, first point, and how many sources are there, that many times we have to find out the solutions. Then we have to add algebraically all the cases solutions. Okay. So find the current in a 6 ohm resistor using principle of superposition for the circuit. Okay. So 6 ohm current we have to find out. So first we have to observe the circuit. We have to follow the procedure. So what is the procedure? We'll see. First we have to observe the circuit. Observe the circuit, and second one is so sources we have to find. So sources, how many sources are there? So we have to deactivate the sources. Deactivate the sources and find the respective parameters. So current means current, or voltage means voltage values we have to find out for cases. So how many cases we have means, so equal to number of sources in the network. Then we have to algebraically we have to add algebraic equations, we have to find out. These 5 steps we have to follow to find the to solve these superposition related problems. Okay. So find the current in 6 ohm resistor using principle of superposition for the circuit. This is the problem is given. First step, so current source you make it as a 0, then find the current source. So you have to eliminate using open circuit. Then circuit will be like this, plus minus, here resistor and here one resistor 6 ohm. So this is the circuit 6 ohm. So this is 3 ohm and this is 6 volts. So this is the circuit. Apply mesh analysis and find the current I1. This is the case 1. I1 current, case 1 current is 6 by 9 amperes. Then so we one next one is voltage source we have to deactivate like this, short circuit, and find the current flowing in 6 ohm resistor. So this is the first case. First case is current source we are making it as a open circuit, and second case we are making voltage source as a short circuit. So apply current division principle. Total current into opposite resistor by total resistance. Okay. Here I2 is equal to, so 2 amperes current. Total current is 2 into opposite resistor 3 divided by total resistance 3 plus 6. So this is I2. Okay. Applying current division principle. So by making voltage source as a short circuit. Okay. Then according to superposition theorem principle, we have to add algebraic currents, algebraically to first case current and second case current. 6 by 9 plus 6 by 9, 12 by 9. So this is a problem based on superposition theorem. Okay. So here we calculated 1 minute. So first we have seen this statement of superposition theorem. So once again I will repeat this theorem. In any linear circuit consisting of multiple independent sources, one, two or more than one, so more than one source. So two sources, three sources. The current or voltage at any point in a network may be calculated as algebraic sum of the individual contribution of each source acting alone. So only one source should be acting, other source we have to deactivate. Action plan. So this is the action plan. So in circuit comprising of many independent sources, only one source is allowed to be activated in the circuit. Four sources are there, so three sources should be deactivated and one source only should be activated. So deactivate a voltage source replacing as a short circuit, and current source should be open circuit. And the response obtained by applying the each source at a time, one at a time, or then adding algebraically to obtain the solution. So we can see this limitations. So we can calculate current and voltage, but we cannot calculate power. So the power is a non-linear. That is the limitations we have discussed. So problem, we have to find the current in the 6 ohm resistor. 6 ohm resistor I1 is equal to 6 by 9 and I2 is equal to 6 by 9. So total current is 12 by 9 amperes. Okay. So open circuit, short circuit we have to make, and I is equal to I1 plus I2 is equal to 12 by 9 amperes. So I1 current is 6 by 9, I2 current is 6 by 9. I1 how we calculated? By opening the current source. I2 by short circuit the voltage source. So 6 by 9, both the cases current is 6 by 9. So I1 is 6 by 9, I2 is 6 by 9. So we have to add according to superposition theorem. So next one, so total current will be 12 by 9 amperes. So this is the problems based on superposition. This problem we will discuss in next video. Okay. So next we will discuss about maximum power theorem. Okay. Thank you everyone.